Today we'll explain about weighted average WI. This means WI. We know WI is equal to XI, small xi, summation of small xi square. So this WI is this WI is a weighted average. Weighted average. However, this WI has some properties. So let's check the properties of WI. The first property is summation of WI is equal to 0. So let's check it how it's happened. So we know WI is equal XI into summation of something like this, right? So let's check it. Okay, so xi is equal to axi minus x bar, and the lowest portion is xi square. Okay, so wi is equal to this. So if we add summation on both sides, it would be like something like summation of xi minus x bar, summation of xi square. But we know the summation of this value is equal to 0, so the above portion would be 0, so the value is 0. So we can say the summation of WI is equal to 0. Okay, the second property is summation of WI square is like 1 by x square. So we have to prove that WI square is something like this. Okay, we know WI is equal to XI summation of XI square. Okay, we all know this. Alright, so if we take a square on both sides, square, and the lowest portion would be square 2. Okay, this one is a square also, you're seeing. Okay, so as there is 2xi, you are seeing that it was summation of xi square again, and here is xi square only, so we can subtract, but the problem is there is no summation here, but there is summation. So what we can do, if we add summation on both sides, this will be similar kinda. So let's take summation on both sides. So summation of xi square and rest xi square whole square. Okay, so what happened? We can subtract 1 from 1, so xi square summation. So summation of WI square is equal to summation 1 by xi square. So this is the second properties. So we want to prove the third properties. That property says summation of WI xi is equal to 1. Okay, so the left hand side is summation of WI xi. We all know WI is equal to x small x divided by summation of xi square, and this xi is in multiplied, so it will be on the upper front. So as we added summation on the side, so the summation will be here. Okay, let's take it, let's break it. So we are breaking the small one. Summation of the small one is what? The small one is large xi minus x bar into xi, and we are breaking this lower portion also. So xi minus x bar, that's a square also. Okay, right, so let's take this point, extend it, xi into xi, so summation of xi square, large xi square minus x bar summation of xi. Alright, So this is what for the upper portion. So let's check this. Law we know, a minus b whole square law, so we're going to apply it. So first one is xi square, so that would be summation of xi square minus 2ab, right, into xi into x bar plus b square. So there would be no summation in this case. Why? Okay. Alright, so this is it, but still we can keep it the summation in here. So the summation here is here, so let's break the point from here again. Keep the upper portion similar, xi square minus x bar summation xi, and this portion is xi square, right, 2 into xi x bar. Check it, here we have summation, so we'll convert the summation into n. So and this x bar has a square, this means 2 x bar in here, so 1 x bar is here, and we're converting another x bar into x summation of xi divided by n. We're just breaking the portion because we know x bar is something like a summation of xi divided by n, right? We all know this, so we just converted the situation like this. Let's check it. This n and n is gone, so how is the situation like? X bar, so your x bar into xi, x bar into xi, so here is a summation also because the summation is added on here also. Okay, so let's take the situation xi square minus 2 xi from this x minus x bar into xi, because n gone, so you're saying these both are same, but it has 2 and it has nothing, so just subtract it. Xi square minus x bar summation of xi, so both are same, so the value is 1. So let's check the primary portion of summation of wiXi, so let's write it here, summation of wiXi. So this is how the summation of wiXi become 1. Thank you.